Hi, Mark Gonzalez. This is my simulation for the Lab 5, where you have the inputs A, B, C in, outputs Y0 and Y1, C out, and then you have the selections for S1 and S0. So the way this circuit works is S0 and S1 will display either a 1 or a 0 and make only one of these AND gates turn on with a 1. And then the idea was to run the circuit that was required and then run that through an AND gate. Because something ANDed with a 1 is itself. So if this is just an OR, it'll go through as the OR, and something ORed with zeros again is still itself. So that is how that works. And then the C0 works the same way. We have the circuit for it. And then if it is the circuit that we want to do that has been selected, it'll be in an AND gate that is also outputting a 1. So it'll go to itself, with the other ones will all be outputting an AND of a 0. So that is how this looks. So for the get set, to start this, so we have at selection 0, 0, Y is going to be displayed as A or B or C in, so we have the C gate. When it's 0, 1, it'll display as NAND AB. When it's 1, 0, it'll be an XNOR of AB, and when it's 1, 1, it'll just be a NOR of AB and C0. If at 0, 0, it will be A and B OR C in plus XOR AB, this weird, or it'll be for 1, 0, it'll be AND AB, which is also known as just not Y in this case. At 1, 0, it is XOR, also known as not Y in this case. And then at 1, 1, it will put as an OR in this case, a not OR, or just not Y in this case. So that is how that puts out. That's why I only have the inverters here that take the input from the Y and put it out. So once we look, we will simulate this. Ticks enabled, and we will look at Y. And as we go through, as long as A, B, or C in is on, it will display a 1. I know it's kind of hard to see, but it's a 0 when all of them are on, and when C out, it displays it in a really weird truth table, but when that line is green, that is also on. Putting it out, and then when we shift to 1, it takes it down, so the Y is no longer working in an OR. It's only based between A, not the NAND of A and B to put out the 1, and C0 and Y are never on at the same time. And that checks out. So then when we make that a 1, it goes to the third circuit. That's the only one that can output. And that works on the same way. These Y and C out are never on at the same time because they're the inverse. And this is based solely on the XNOR of A and B. And then the last one is the 1, 1, where it takes the fourth circuit. That's the only one that can turn this on. And C out and Y are again not beating on the same time. I do believe that's everything.